Hi, my name's Zampano, and this is the project for the school. It's about the Earth from space. So here, me and my dad created a project of Earth that can spin. It also has Britain on here with a little flag. As a moon, which can also spin and goes around the Earth. And finally, the Earth can go around the sun, which is this big ball of light. There are a few things to this project. The first thing is day and night. The Earth moves every 24 hours. So this is day in Britain because it's receiving the most light, but it is night over here because it's receiving no light at all. But when it turns around, it'll be day over here, but night over here. So that's pretty much the day and night cycle. Then there are seasons. Because of the angle of the Earth, it will have seasons. So here it's winter because Britain's barely receiving any light. But if we move it over here, if we move it over here, it's summer because Britain is receiving the most light, as you can see here. The third thing is the phases of the moons. So you can see the moon because of the light reflected off it. So if it's night in Britain, then, and it was here, it's a half moon because the light's reflecting on half the moon, not the whole moon. So Britain would see a half moon. And the moon also only moves around every 28 days. So a full moon cycle, so it would take 28 days for the moon to go here all the way to here. So here would be a half moon, since only half the sunlight is reflecting on the moon, but the other isn't here. Now, this project's inaccurate, so this should be a full moon, but if it was the correct distance to the Earth, it would actually show, but now you can only see black since the Earth is blocking the sun. But in real life, if it was the correct distance, it would show, and this was a brighter light. So this is a full moon, and this is about a crescent moon, because you can only see a very slight slither of a moon. And then of course this is no moon. The second to final thing is eclipses. There's two types of eclipses, a solar eclipse and a lunar eclipse. Both of these eclipses don't happen as much, but since our project is inaccurate, they're very frequent. But in real life they aren't. So, firstly, this is a solar eclipse. Can you see this dark shadow? It's because the moon is blocking the sun's light. So over here it will be pitch black, but over here it will be light. So that is a solar eclipse. Then we have a lunar eclipse. This is the problem I mentioned to you before. The Earth is blocking the moon. In real life this would be much less frequent, but the Earth is blocking the sun's light from reaching the moon. Then there's one more thing, tides. So tides are happened because of the gravitational force of the moon and sun. So here, the moon's pulling the water out this way, but the sun's pulling the water out this way. So it'll be a high tide in, let's say, Britain and here, but it'll be a very low tide here and here. Then, there is a spring tide. A spring tide is where the sun and moon are working together to pull the water. So here it's a spring. So here it will be a very high tide, and also here because of complicated gravitational reasons. But it'll be a low tide here and here, and it'll be a very high tide here because of the moon and sun. So this is the highest tide. Then there's a neap tide. where the sun and moon are working against each other. So, but the moon's gravitational force is stronger because it's closer to the Earth. So it beats the sun. So here and here will receive low tide, but Britain and here would receive a high tide, but it wouldn't be so high because the sun's still fighting against the moon. So it'll only be a slight change. So that's basically it.